lesson 2-1 and 2-2, looking at relationships and figuring out if they're proportional or not. We've been looking at proportions lately, and we've seen that proportions have a constant. There are two equal ratios, and if ratios are equal, it means they have a constant rate of change. So these are proportional. You'll see there's a constant steady amount of water used over time. They never use more water or less water. It is consistent all the way through. This sloth is walking at a consistent speed. Each um, each minute, it's going 3 feet. So, and it's staying at that rate consistently. It's not going any faster or any slower. Notice that I added dots to that line just to help me like understand the question. That's fine to do. These over here are all non-proportional. This one's not proportional because it didn't start at 0, 0. This one here is not proportional because it's curved, curved, curved. So there's two things that we're looking for a constant rate of change, that it starts at 0, 0, starts, or actually I should say goes through. Doesn't necessarily need to start there. It needs to go through the point 0, 0. See, this one doesn't go through 0, 0, and this one doesn't go through 0, and it's straight. Both things have to be true, not just one. When you're looking at a table to figure out if something's proportional, it needs to have a constant rate of one for the other. It doesn't ever get more or less. And so when you're looking at these, you're saying, is there a rule that is multiplying that I can use every time to get from here to here? You can figure out that rule by taking the second value and dividing it by the first. So 1 divided by 2 is 0.5. Ella, it's fine. Okay. 2 divided by 4 is 0.5. This should always be constant, saying that the rule is timesing by a half. Here we see the rule is timesing by 13. 2 times 13 is 26. I can see that by doing 26 divided by 2. 13 times 3. 13 times 6. 13 times 10. So these are both consistent because it's the same rule every time. And that rule is multiplication. Over here, it doesn't look consistent. This looks like maybe it's adding 1, but then this is adding 2, this is adding 3, this is adding 4. There's no consistent multiplying rule. So if I look here, the rule, if it was multiplying, would have to be timesing by 3, and it doesn't work here. As soon as you find something that it doesn't work, it can't be right. This would be a 0 if I times by 3. So here, it looks like the rule is again timesing by 3. It needs to work every time. If I try timesing this by 3, it doesn't work. It doesn't work. It doesn't get me what I'm looking for. So you can also check to see that their y over x ratios are not the same. This one was 3. This one was 18 divided by 3, which is 6. So it's not the same multiplying rule. Okay, so the summary is you need the same multiplying rule each time. So here we find equations that are proportional. All of these have one number that we're multiplying by. Those are all proportional. We're multiplying only. The problem over here is that you can't have any addition or you can't have subtraction or exponents. Multiplication only. Can't have adding, can't have subtracting, can't have exponents, can't have adding, even if there was a multiplying part in there. So all of this row of the paper was non-proportional. The notes here, there's not a whole lot to copy. That you have a photocopy of this. So again, if you're looking at a graph, for it to be proportional, it needs to be straight and go through the origin. If you're looking at a chart, whether that chart goes this way or this way, you're looking for the same rule to get from the left to the right. To find that rule, take your y and divide it by your x. 1 divided by 3. This would be the same information just in a chart going horizontally instead of vertically. And then if you have a word problem, you would need to think about it. Would it start at 0, 0? Would Mrs. Ring's dog need 0 cups of dog food for 0 days? Yes. Is there a constant amount that it's going to eat, he or she's going to eat every day? Yes. And when you're looking at an equation, remember it can only have multiplying, no addition, no subtraction. All of these are not proportional. Let's look at a couple of your homework problems. Let's look at a couple of your homework problems. The first ones are so easy that sometimes kids get confused. So all they're telling you is take y and divide it by x. They're getting used to having you find the constant of proportionality that we're going to do on Thursday. So take 12 and divide it by 3, and that gets you 4. And take 16 and divide it by 4 and see what you get. You're going to quickly see a pattern emerge here. And I'm not going to do the rest of the problem for you. The next one is decide whether the table shows a proportional relationship. So you can figure that out by checking out the y over the x. Y over x tells you what the rule is. So this one's timesing by 2. Okay, this tells you what the rule is, and this needs to be the same rule for this to be true. Is 4 times 2 16? Is 7 times 2 49? The rule has to be the same for it to work. Okay, so think about that. Is every one of these timesing by 2? Did this work if I times them all by 2? This shows a proportional relationship. And Dimitri says that the rule is 1 over 10. Is that right, that you're multiplying by 1/10 each time? Think about that. Take your y and divide it by your x and think about what you get. Okay. Is this number the same as this number? Remember that the rule is y over x. On this one, you're looking for which one is proportional. Look back at your notes. You're looking for something that's straight and goes to the origin. This one, you're looking for something that's not proportional. Here, you're looking at the equation and you're looking for something that only has addition. And if it, only has multiplication. Only multiplication, because if it only has multiplication, it'll be straight and go through the origin. Unlike something that has addition in it. If something has addition in it, it won't go through the origin. It still may be straight, but it won't go through 0, 0. When you plug in 0 here, you would get 4 for your y. So this problem would graph as being a straight line, but it wouldn't go through the origin. When you plug in 1, you'd get out 7. Let's look at a couple others. So let's see. How many would he bake in 4 minutes? You'd go up on the graph and then you'd look over to answer that question. Go up to where it hits the graph. What does the point 0, 0 represent? Well, for 0 cups of flour, you're going to get 0 cookies. Okay, so what does the point, maybe this one right here, represent? That represents 7 and 125. So that point there would represent 7 cups of flour gives you 125 cookies. This is cups and this is cookies. And then this one here, you're going to look back at your notes to figure out if that is proportional or not.